because collaboration is what we're getting ready to do with this final project. And what I want us to do is think about this and then utilize these concepts in Project 3. And now, before I jump in and talk about that, I do want to make sure we're up to speed on where we are in class. So let me just go into here. And what we have, of course, what are we at today? The 13th. Yeah, so the project user interface design is due today. And as we talked about, what I want to see is I want to see a picture of what your screens look like, and then I want to see a description of how it works. And oftentimes the best way to at this, basically what we're kind of doing is we're working through the design process, and systems are oftentimes, especially systems that are user-oriented, are designed from the outside in. First, we come up with our conceptual design. What in general do we want to do? And then we get a little more specific and say, how do we want it to look and feel? And in the process of doing that, oftentimes what we do is we tell user stories. In other words, we literally say, well, you know, Elizabeth sits down in front of her computer and, you know, she goes to check her art page, and the first thing she sees is, you know, maybe 2 pictures that everybody's talking about today, or maybe the most popular picture, and she interacts on that. You know, she maybe posts a comment on that, responds to some of the other people's comments. You know, you go through and you kind of tell a story, and you're a little more specific than I just said, but you tell exactly what it is that you want a person to see and do as they're working with the system, because it's important to think from that perspective. And it's important to understand what you want the program to do before you try to design how it's going to work behind the scenes, because you're probably not going to design it right if you don't actually know how it needs to work. Hang on here. And so that's what's due today. Now, the design on the 16th is due, and that's where I expect you to sit down and think in terms of both architecturally, what pieces of it go where, you know, what are the major pieces, and then what are those major pieces made out of. For example, if you're doing Node.js, you're going to have JavaScript running in the web page, and you need to think about how that's broken down into components. And you're going to have stuff running on the server side, and you need to think about how that's broken down into components, right? So you need to show that the architecture shows the major pieces, and then the class design shows how those pieces are broken down into classes and functions and other components. You know, there's, you know, so quite likely, for example, if you're using Node.js, you have the web stuff, the stuff that's running on the web page, you have the Node.js program, and you have the database. Okay. So that's, and in general, let me say, when you turn things in as a team, I expect you all to turn in exactly the same thing, right? I want to see that you're working together, right? On the conceptual design, I kind of got different things from different people on the same team, which kind of surprised me and concerned me a little bit, because it would perhaps seem to indicate that you're not working together as closely as I would like to see you work together. Any questions on any of that stuff so far? Okay, so the last non-project oriented assignment is here on November 18th, and I wanted to talk about that for a second. Oh, why did I edit that? I don't get that. Okay, so open in a new tab. Weird. Edit page. Huh. That's weird. Okay. So, huh, that's weird. Okay, so I'm not sure. I'm not sure what happened here. This page is a little quirky. So let me fix it here. But anyway, what I want you to do, and this is just an assignment to sort of require you to dig in to one of the Node.js apps that you got up and running and add some features, so I know that you actually kind of have a feel for how these programs work. And so what I'm asking you to do is either modify phone node rest or modify socket chat in the following way. If you're going to do the first, modifying phone, there we go, this should be add features to node.js program. Okay. And I don't have any idea what this is. Okay. So if you're going to pick Node.js, what I want you to do is basically take it and make a new thing that does the same thing, right? So make a new database. And what I want you to make is make a task app that it has a task string, a due date, a task status, and a comment on the task. And then use a date picker. You can explore this to see what it means, but you've used these before. This is when you click on something and you get a little calendar pops up and you can pick a date. And use a pull down for the task status. And again, I go through and I give you things that I want you to do to create this little app. Now, this shouldn't take a lot of time. You're basically just taking an existing app and hooking it up to a new database table and changing some of the features. So this is basically just make a new little app. Now, by the way, well, no, not by the way, forget that. The other option is to take the socket chat thing and add a database to it so that it keeps track of everybody's messages over time. So even if you stop the program and restart it, you can actually go in there and look up a history of the chat. Okay, and so probably what you're gonna do for your database is you're gonna have a date timestamp for the comment, the sender's name, and the message, and that's gonna all be pushed over to a database. Okay, so those are your two options. Again, I don't anticipate, if this takes more than a couple of hours, then you're doing something wrong, right? But I wanted you to get your hands into the Node.js to help you, especially to help you know these technologies, and to especially help you if you're going to make your project using Node.js. Any questions on that? And so, let me do one other thing here. I'm just curious. So here's the teams that we have so far. I still need meeting times and a meeting link from this team. The first team, by the way, are you guys planning on doing the art? Is everybody doing the art, or is anybody planning on doing a game? I think everybody's.
Yeah, we are all doing art, and right, we're using Python.
And you guys are using Python. This group is using JavaScript. What about, I said question mark. Have you guys decided what language you're going to use? Or if you're still thinking, that's okay. I'm just curious. No comments?
I think we're leaning toward Node.js and JavaScript.
Okay. Well, I'm not forcing you to make this decision now. I was just curious where you're at on that. That just helps me. Okay, thank you. All right. So that sort of brings us up to date with where we're at, what's due. All right, collaborative construction. So the whole thing, oops. So we're going to talk about the values and why and how we do collaborative programming. Now, so here's the thing. The primary purpose of collaborative construction is to improve quality. Now, when we talk about collaborative construction, we're not talking about just a team where each person is given something and they do their thing and then somebody else maybe pulls the pieces together. That's a team, but that's not collaborative so much, right? Collaborative is when you're in a detailed way interacting with each other and collaborating with each other on the same stuff, okay? Now, I'm gonna go through a series of slides and it's a lot of stuff, but what I'm trying to do is really get you to understand just how valuable this is. Software testing has a limited effectiveness when used alone. If that's all you do is you write code and you test, it basically only finds on average about 30 to 35% of the errors that are in the code, which is pretty poor, right? That means 65 to 70% of the errors are still in there. The average effectiveness of design and code inspections are 55 to 60%. Let's see what we mean by that. And we'll look at that in a second. The second thing is collaborative construction actually decreases the development time and the development costs. Now, what's interesting is people who don't use this method largely don't use it because they think it's a waste of time, which is exactly the opposite. They say, no, we got to get things done. We don't have time to talk. We got to work, 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 right? And it turns out that that's counterproductive. It's counterproductive to just think that we're all going to focus on our work and we're not going to interact with each other. IBM found out that each hour of inspection, looking at somebody else's code, inspecting it, and saying, hey, this is what I found when I looked at your code, prevented 100 hours of related work for every hour put into it. That's a 100-to-1 ratio. Isn't that stunning? I mean, it's shocking that 1 hour, if you actually know that 1 hour will save you on average 100 hours, if you're not doing it, you're crazy, right? Raytheon reduced its cost of defect correction rework from about 40% of the total project to about 20% through an initiative that focused on inspections. So, you know, if you have a total project that cost $1 million, this is $200,000 in savings, right? Hewlett-Packard reported that its inspection program saved an estimated $21.5 million per year just because they started inspecting. Imperial Chemical Studies found that the cost of maintaining a profile of about 400 programs was only 10% as high as the cost of maintaining a similar set of programs that had not been inspected. So that's a 10 times improvement. A study of large programs found that each hour spent on inspections avoided an average of 33 hours of maintenance work, and that inspections were up to 20 times more efficient than testing. So it turns out that actually looking at your code is better than running tests, which again, I think for many people is counterintuitive. They think, well, I don't know what the code does unless I run it. And that's true. You do have to run it. Nobody's saying you don't run your code and test it. But testing is not as effective as looking, because testing only tests the things that you do. Looking, you look at everything, right? And I can't tell you the number of times when I've been working on large, difficult commercial products that are going to be delivered, that I have spent time reading through my code that I have tested the heck out of. I have tested it and tested it and tested it and tested it, not seen any errors. Then I look at the code and I realize, oh my goodness, there's an error. I just never created a situation where that error occurred, but it was in there. In a software maintenance organization, 55% of one-line maintenance changes were an error before the code reviews were introduced. In other words, you got a problem in your code, there's an error, somebody reports an error, somebody goes in there and says, okay, I'm gonna fix it. They find a line of code, they say, this will fix it, and they make a few changes. How many times have you done that, right? And this says that 55% of those fixes were wrong. Whereas only 2% were wrong if there was a process of having somebody else review the fix, right? Now again, the temptation here, if you're running a company, is to say, man, time is money, we've got to move. And they might say, well, that's a simple change, just do it and go, right? But why waste the time of some of our other expensive engineers looking at code? Because we know old Sam is doing okay over there. We don't need to look over his shoulders. In fact, maybe even in some cases, people might feel like, I don't want other people to look at my code. Bad idea, right? There's other aspects of this, by the way, that we could talk about, and we will actually talk about in some future classes, but there's a culture of programming. And when you're working on a software development group, the culture, on one hand, kind of one end of the continuum, it could be every man for themselves, every person for themselves, trying to do the best they can, and maybe even show up the other people, versus we're all in this together, and we all succeed together, or we fail together, and we can help each other, and we all benefit from that, right? There's a team ownership, right? When all changes are considered, 95% were correct the first time when reviews were used, versus 20% when no reviews were used. Only 1 in 5 was right when they didn't use reviews. A group of 11 programs were developed by the same group of people, and all were released into production. The first 5 were developed without code reviews, and they had 4.5 errors per 100 lines of code. I mean, they literally went in and they looked at this carefully. Then they looked at the 6 that were inspected, and those had less than 1 line per 100 lines of code in error on average. So the reviews cut the errors by over 80%. Yeah, are you starting to buy this now? In software maintenance organizations, 55% of one-line maintenance changes were an error before codes were introduced. After code reviews were introduced, only 2% of changes were an error. Huge difference. This is another study. When all changes were considered, 95% were correct the first time when reviews were used. Only 20% were correct when reviews were not used. Casper Jones reports that of all software projects he has studied that achieved 99% defect removal rates or better, all used formal inspections. none of the projects that achieve less than 75% defect removal efficiency used formal inspections. Okay, so inspections matter. Now there's different types of inspections. The book talked about that. We'll get to that. But first, let me take a little bit of an aside here. And this kind of goes to the culture of software development. It has to do with something called mentoring. Now, when we look at each other's code, it's more than one person just pointing out in the other person, that's a problem, right? And then maybe the person gets embarrassed and saying, oh, right? There's a lot more than that. It can be a mentoring thing, because it's almost always the case that you have people at different levels. You have newer people, younger people, less experienced people, and you have more advanced people. Or you could have two people who are more or less at the same level, but one has more experience in one area and the other has more experience in the other area. And in general, people can mentor other people, whether or not they're at the same level or different levels. In fact, it can sometimes be the case that a new person maybe learns something that a more advanced person hasn't learned yet, and they can tell them about it, right? That's a possibility. We can learn from each other. So reviewing provides an opportunity for mentoring, because when we look at code, we can say, you know, I see what you did there, and there's a really cool way you could do that in half the lines of code, much more likely to be correct and way more efficient, right? And so there's learning that's going on, there's mentoring. This doesn't have to be threatening, right? If it's a culture where people care about each other, where people want to help each other, where people want the team to be a better team because they all benefit. This, you know, mentoring can make things better. Okay, so reviews create a venue for more experienced and less computer experienced programmers to communicate about technical issues, right? So when, for example, when the less experienced program stands in front of a conference room and shows their code to more experienced people, the more experienced people can help them improve their code. And by the way, other less experienced people who are sitting in the room but not presenting, they're learning as well. Now, conversely, let's say there's a more experienced person presenting and there's some less experienced people in the room. Well, they're learning too, because they're seeing this better code typically, and they're learning from it, right? So there's all sorts of learning going on. And so these reviews aren't just helping the code, they're helping the people become better, right? That's a part of the review. It's not just making the code better, it's making the people better. Pretty cool concept, right? And in general, I mean, and I like this because one of the reasons I became a professor is I like people, I like interacting with people, and I like helping people. And, we can, in an organization, can foster and cultivate an environment where there's constant improvement. And the improvement is non-threatening, right? The critiques are not, well, boy, that was stupid, but more, hey, here's another way you could do that. Or, by the way, that's going to result in an error occasionally. Let me explain why. A big part of this is the culture. When people work together as a group, there's collective ownership. Oftentimes when I work, you guys are entering into your team work phase now. And too many times I've worked with teams where when the product doesn't work, or it doesn't, doesn't work right, or it fails at a certain point, or major features are missing, I'll talk to the individual team members and they'll point their finger and say, well, that's Bill's fault. He wasn't very engaged, right? No, it's not Bill's fault. It's everyone's fault if you're a team, because everybody should be responsible for everything collectively, right? Collective ownership means everybody's involved. And when everybody's involved, everybody's looking at everybody else's code. Everybody's helping everybody. People are coming to each other and saying, I'm struggling with this. Can we work on this together, right? Instead of just saying, well, I hope Bill's doing his work because I'm doing mine, right? That's not collective ownership. So the result of everybody working together, everybody being serious about every piece, is you get better code. Multiple eyes look over everything. Now, you're hopefully not going to have this, but when you have collective ownership, if somebody leaves, we don't have this problem where, oh, well, Bill wrote all that and none of us have any idea what the hell he was doing, right? It just worked and so we didn't care. That's not a good situation to be in. Defect correction cycles are shorter because any of several programmers can potentially fix the problem, because there's several programmers who understand the code. It's not just, it's not just this is Bill's code and this is Nancy's code. This is all our code. Now, one methodology that's become quite common in industry is something called pair programming. Pair programming is this notion when literally two people sit together and they work side by side on the same program. Now, typically one person has the keyboard and the other one is watching, but they're both fully engaged. Now, it's kind of interesting. I learned about this when I was in college, even though nobody was talking about it yet. My roommate and I started a company, and we were doing software for this engineering firm in Knox County that built industrial control systems. And this is in the 70s, and computers were hideously expensive then, right? Nobody had their own computers. We didn't have our own computers. We didn't go into work with a laptop, right? We would, and so there was one development system, and we had to both share it. And this turned out to be really good because my friend Russ and I would sit beside each other, and he would usually type because he was the better typer than me. And we would talk and argue and generally work together. And we wrote code. We were just a couple of college juniors, and we were writing code that was being delivered all over the world for a variety of purposes. And some of that code is still being used today for products. And they hired us because this was a company of electrical engineers who were building controller systems, but they didn't know how to program them. And so we came in and programmed them for them. And I think one of the reasons we did so good was because we worked together as a pair. And in fact, the reason we initially got hired was because there was this company that came in and wrote a bunch of software for them, and none of it worked. And they hired us to fix it. And and I actually knew that other company because the company was owned by a guy who'd gone to the same college as I did. And after he graduated, he hired some other students who were older than me, and they had this company, and they were doing projects and they were writing crap code. And I happened to know that they were not doing any collaboration. They just would say, one person, you do this, and another person, you do that. And the code they wrote was absolute crap. So when it didn't work, the president of this other company, he called me in and said, can you fix this program? And I remember one program in particular there was this truck that Goodyear had bought. It was a Chevy truck, and it had jacks built into it, so you could push a button and it would jack it up off the ground, and you could change the tires. And this company had put a computer into the truck, and it would literally take over the throttle, and it would try to spin the tires. And what you would do is take it out into wet surfaces, dry surfaces, sandy surfaces, snowy surfaces. And what they could do is they could push the button, and it would automatically accelerate the vehicle, the computer would, and it had all these sensors so that it could sense what was going on and give statistical information on how well the different tires did with different rubbers and different tread patterns would do on different types of surfaces at different temperatures, etc. So this other company, that they had they built the hardware, put it in the truck, and this other company had written the software for them. Didn't work at all. So the president of the company called me up, a college junior, and said, "Can you fix it?" And I looked at it, and it was utter crap. And I said, "No." I said, "I will, for a half of what they charged you, I will throw their code away, and we will write a new version that will work." And we did, and they delivered it, and it worked. Goodyear used it, and in fact, they liked it so much, they're now on their 7th truck. Every few years, they build a new one. So anyway, collaboration matters. Pair programming works. Now, the key of pair programming is support pair programming with coding standards. Most companies you go work with are going to have coding standards. They're going to say things like, this is how you indent the code. This is how you comment on the code. This is how we pass parameters. You know, these are ways in which we've decided we're going to do things. Don't let pair programming turn into watching. Both people need to be engaged. Don't force pair programming of the easy stuff, right? If something is really simple, you don't have to do code program, pair programming. Do it for the stuff that's challenging. Rotate pairs. Encourage pairs to match each other's pace. Make sure both partners can see the monitor, obviously. Don't force people who don't like each other to pair, and avoid pairing a couple of newbies because neither one of them knows what they're doing, right? But in fact, if you have a more junior and more senior person paired together, there's not just helping each other, they're actually learning. The junior one is learning a lot. Assign a team leader. So, benefits of programming. It holds up better under stress than solo development. It's been shown by research that it greatly improves code quality. It shortens time. Now, here's the thing. The temptation is to think two people writing programs separately are going to produce code faster than two people working together. But there's this constant review process going on. As we saw in the previous slide, reviewing reduces error, which reduces the time it takes to fix the code so it can actually be delivered. And research has shown over and over and over again that it actually takes less time to write a program using a pair than using individuals. Okay, so this is why I want you to do pair programming as part of your final project. Now, the way to do that is obviously to get together on Zoom or Google or whatever, have one person share their screen, and the one who's writing the code and the other person is watching, and they're talking about it as they code, right? I want you to do that. I'm going to be talking to you about that and checking to make sure that you are doing that. It produces all the other general benefits of collaborative construction, including disseminating corporate culture, mentoring junior programmers, and fostering collective ownership. All of these things are part of pair programming. Formal inspections. An inspection is a specific kind of review that has been shown to be extremely effective in detecting defects and to be relatively economical compared to testing. Now, inspecting occurs all over, and not just in programming, right? Have you ever gotten a pair of pants or a pair of shoes or something, and when you open up the box, you see a little slip in there that says inspected by Inspector 37. Have you ever seen something like that? Right? Companies that want to be successful, they inspect all their products. They have an inspector who looks at the product to make sure they're not sending out junk, right? And there's a formal inspection process. And so companies that are successful have built into their organization formal processes of reviewing the work. This is not the same as an informal review. An informal review is when you just get together with somebody and say, hey, would you take a look at my code and let's talk about it for a little bit? That's an informal inspection. But a formal inspection is a thing where you set a time and you pick a person and say, you're going to show this code, and everybody gets the code ahead of time and they read through it. And then they all come to the conference room, and the person whose code it is puts his code up on the screen and stands there and talks about his code, and everybody else makes comments on it. It's kind of a scary thing to do at first. I've done this before with companies, both as the person at the front and as the person watching the code. Now, this inspections focuses on defect detection, looking for problems in the code. The reviewers prepare for the inspection, and they've already looked at the code. So they have comments. They're saying, okay, you just got to line 19. I was looking at this, and this is what I saw. Distinct roles are assigned to participants that we're going to see, and there's a moderator that isn't the author who moderates the whole process. Typically, in these formal inspections, a monitor has received specific training in moderating inspections, and the inspection meeting is only held if everybody is prepared for it. Now, you can see this is a pretty big process, right? Everybody, somebody is picked to do a review on some code. That code is printed out, or probably not printed out, but it's sent to all the people. They're asked to spend some of their valuable time looking at that code, and then they all come together and they work together and they look at the code, right? A lot of time goes into this, but it's shown to be effective. So one of the questions on the quiz was, who doesn't come to the meeting? And that was the general management. Why do you think the general management doesn't come?
Because they're more like your boss, and it feels more like they're inspecting you rather than your code.
Right, yeah. Yeah, and for one thing, general management probably doesn't even know that much about coding, right? And you don't want this to be threatening. Exactly. You don't want to be threatened by it. You want this to be a team that's working together to make things better, right? And so by the time general management sees the code, everybody knows about the code, everybody understands the code, and everybody feels a collective ownership of the code, right? Can you see how this builds a community of quality? And that's what we want to do. So there's a bunch more statistics here, right? So combination of design and code inspection usually removes 75 to 85% or more of defects in the product. Inspections identify error-prone classes earlier. Casper-Jones reports that they result in 20 to 30% fewer defects per 1,000 lines. Designers and coders learn to improve their code through participating in inspections, and inspections increase productivity by about 20%. So it turns out that inspections improve the output, even though we're spending valuable time. I mean, if you get 5 programmers in a room and they're looking at each other's code for an hour, that's 5 hours that it seems like you're wasting. But no, you're not wasting it because you're spending so much less time fixing things that got screwed up. On a project that uses inspections for design and code, the inspections will take up about 15% of the project budget and will typically reduce the overall project result. So during an inspection, you have a moderator, the author of the code, a reviewer, one or more reviewers, a scribe, somebody who keeps track of what happens, and maybe management. So moderator is responsible for keeping things moving. I'm just going to jump beyond that. The author is the person who wrote the code, and they are presenting their code so that everybody can talk about it. So somebody might say, well, what are you doing here? And then it's their job to say, well, this is what I'm trying to do. This is why I did this way and not a different way. And then a reviewer is anyone who has a direct interest in the design or the code, but is not the author. Could be other programmers, could be higher level designers or architectural engineers. And the role of the reviewer is to look for problems. And then the scribe writes down all the problems so that, so that the author doesn't have to do that. And then they can get all of that stuff written up so they can go back and then work on what the findings were. So we talked about management is not who we generally want there. Okay? People feel threatened if management is there. So, I'm just trying to see how much more do I have, because I don't have a lot of time. So the book goes through this whole process of how you do an inspection, right? There's planning, there's overview, preparation, there's the actual meeting, there's the report. People do the rework based on what came out of the meeting. There might be some follow-up. Somebody might say, hey, I want to see what the results are. And then there's this concept of a third-hour meeting. So, planning, these things require planning. The author has to give their code to the moderator. The moderator decides who it makes sense to look at the code. And typically everybody is given the materials printed with line numbers, or if it's in a document, you want to have line numbers in there so you can say, I want to talk about line number 74 in this file. If the reviewers don't intimately know the context of this software, there might be some time where the author explains the overall context, the overall technical environment. And they may do that. Hopefully, the point, really, I don't want to read through all this, but the point is hopefully the reviewers will mostly know what's going on, because if they don't, you're going to be spending too much time talking about it and not actually looking at it. Reviewers are supposed to look at the code before the meeting. I'm going to jump ahead. You have the actual meeting, go through all the code, you record all the findings, and then the scribe produces a report that lists each defect, including its type and severity. And that goes out to everybody, but it especially goes to the author so the author can work on it. Now, the moderator assigns the defect to somebody, usually the author. Could be a special situation where it isn't, but usually it is. And then the moderator is responsible for seeing that all the rework assigned is carried out. Now, if it was a really messed up code, right? If there's some serious problems, there may be another review. Now, there's this concept of a third-hour meeting. Even though during the inspection, participants aren't allowed to discuss solutions, it turns out. In an informal inspection, based on these rules, you're not supposed to talk about the solutions. You're supposed to talk about the problems. Solutions are done separately. However, if there's people in the group that says, you know, I think I have a solution for that problem, what can happen is after the meeting is over, people can put their heads together and have what's called this third-hour meeting to actually talk about possible solutions. Big issue, and this is a cultural issue, right? You have to put your egos aside. You have to be able to go into a room and accept that your code isn't perfect. And it's not going to be perfect. Nobody writes perfect code. Nobody. It's not possible. That's been proven over and over again. And so, you know, it's important that there's a culture where you're talking about problems in the code and you're not talking about problems with the author. You know, like, why do you always do that? Or you don't seem to understand, or, right? Those are the wrong sort of approaches. The approaches is, I don't think that that method will work, or that's potentially going to cause a problem because under certain circumstances, you're going to have a null pointer, right? So the experience in the end should be positive. The coder should be encouraged to become a better coder. I'm trying to think if I want to, I think I'm going to leave it at that. So again, what I want you guys to do is I want you guys to work as a collaboration. I want you to work together, spend time looking at each other's code, do some pair programming. Try to take a group ownership of the code. Every piece of code should be looked at by more than the author's eyes. Okay, that's my challenge to you. And see how much more productive you actually are, and how the code tends to work more rather than less. And so, and in the end, how you can build a product that you're all proud of, right? Again, avoid just slicing it up into pieces and then giving everybody their little piece and just letting them do that. Please try to avoid that, right? I want this to be a learning experience where you're learning how to develop good software, but I want you to learn how to develop software as a collection of people. All right, so that's the end of the class. I hope you guys have a good weekend. I look forward to seeing your user interface designs, and you know, dream big, but try to keep it within reasonability. So take care. See ya.
Thank you. Bye.
Thank you, Professor.
Professor, I had a short question
Okay.
about the update to the Node.js app.
Yes.
So I was going to start working on the socket chat.
Okay.
And I was wondering, when you're adding an additional query, I suppose, like one of the features we're supposed to add is have something that'll that'll send the search terms and you'll get back a list of messages based on users.
Right.
And I was just wondering, how do you set up a new
Oh, okay.
thing
Okay.
like that?
Let me look at the code and let me see.
As in, do you do a separate socket? Do you try and work it
I
into
w-
the
yeah,
existing
I don't.
message?
Yeah, I wouldn't put a second socket in. I don't. You probably could do that, but let me bring up the code and repositories. Okay, socket chat. There we go. All right. So the way socket chat works, you think you can see my screen now? Yeah, so the way socket chat works is the client sends a message, but basically both sides are sending messages to other people. And a message is made up of an operation, is basically made up of fields, right? So here, we got message partners, message name, message operation. And so what I would do is simply add a new operation, which is just going to be a string. And then if you want to add additional fields, you can just add those fields, right? This is the cool thing about JavaScript is you can just add things anytime you want, right? You just add a new field. So,
Okay, so even though it's going to be associated with a different part of the HTML and everything, it's still fine to just have it as part of that.
right. So are you planning on having just two different pages, completely different pages?
No, it's just more like it would be through a different search field with a different
Right,
search
right,
button.
yeah, that should be fine. So
All right, okay.
when they click it, right, for example, here what we see is, where is it here? So document ready. Down here, if they hit the leave button, it calls leave session, right? If they hit the send button, it calls send text. It actually turns out every time there's a key up, it sends text, and that's what makes it live. And so you can add functions, and notice the way the function works is we build a message, right? So I admit something called a message, and here's the contents of the message, and the contents are always attributes and values. And so you can build any message you want. I could build a message that has an operation of, lookup, and then maybe it sends a search field. Search field is equal to a search field, right? Or something like that. And then at the other end, when I notice that the message is lookup, I say, if it's lookup, then I pick the function that I call, right? Does that make sense?
Okay. Yeah, that makes a lot of sense. And should it be pretty easy to figure out how to just send it back to the person who requested it rather than
Yeah.
to everyone?
Yes, I guess okay, so that's a very good question. So let me remember how to do that
I
myself.
recall seeing in the chat app that a lot of them used broadcast, so I figure it's
Right,
probably a matter of changing that.
Yeah, so basically, if you get a message, I think when you admit, it just goes back to the sender. Socket.broadcast goes to everybody but the sender. Just admit goes only to the sender.
Okay.
It's that easy.
Yeah, I was probably overthinking it a bit. Thank you.
Okay, good. Hey, have a good day.
You too.